Currently waiting for RPI-sec.
Yep, that sounds about right. It's probably started.
I think I'll stay muted.
Yeah. Call this a fun first run of live streaming a talk because, well, it is. Hopefully it goes well.
Oh, hey, there we go.
Oh, and for all of y'all in chat or on YouTube, we got
Working.
an audience in Mumble because you got to get that true experience of the hecklers in the audience.
Wait, one sec. I'm going to make you the priority speaker so that you're louder than everyone else.
That does... I can just change the volume of the stream.
Okay, that also works.
But I guess that works. OBS has forgotten where all of its windows go. Thank you, OBS. All right. I guess get started then, because well, it's a live stream, so people will show up if they show up, and if they don't, they don't.
Oh, man. Starting on time?
I mean, I can wait the customary 5 minutes.
Nah, don't bother.
There's a bunch of slides.
It's pre-recorded.
Pre-recorded. You
Yeah,
can tell it's pre-recorded because if it wasn't pre-recorded, I don't know. I ran out of an idea.
Okay,
right.
you can rewind the stream, so it's fine.
I can just take the start of this stream and cut off all the talking at the front.
You could. That's probably a good idea.
Hello.
Hello.
Hi.
Welcome to the stream. We're about to get started.
You're live on air.
Where's the link?
Your output. Actually,
It is in general.
Yeah.
There is a link in general. Look at that. Have fun listening to all yourselves because I got desktop audio on.
Oh, I have the stream muted.
That works. I love how like 50% of the things on my dock cause my screen to switch. It's real convenient. All right, I think that's enough waiting. I'll get started. All right, so hello everyone. We're talking about code injection and game hacking on macOS because Matt spent a couple weeks doing this talk for Windows, and we got a lot of background knowledge. And see what it looks like on macOS instead. I'll give you a spoiler alert. It is a lot messier. But it is possible. It is possible. So, oh yeah, here's the refresher. So we've been using Assault Cube as a kind of classic game because, you know, it's a shooter. It's got like no protections, and it's pretty easy to hack into. And with Windows, you know, you had a bunch of mess with handles and processes. So it was reasonable. It was all like defined and stuff. But you see, Windows is an inferior operating system. I use only the finest, macOS 10.14 specifically, so that way I can run the 32-bit games. Catalina, it's going to happen when I buy a laptop that doesn't have support for the old ones. So can I play Assault Cube? Sort of. I can still play Assault Cube for now. Can I still cheat at Assault Cube, though? Well, hey, that's what the talk's about, so hey, let's find out. So, yeah, as I said, Matt mentioned that macOS was a lot messier than Windows. But the real question is, how much messier? Well, it turns out it's a lot messier. Yeah, warning in advance. So, but hey, let's give it a shot. So, what's the first thing you probably think of when you start porting all of your cheats to macOS? Well, let's just try it. And as you can see here, I have taken the Windows hack and just thrown it into GCC. Sometimes it's that easy, right? Please, can it be that easy? No, it's never that easy. You don't have Windows.h. But hey, you know what? I installed all this stuff for .NET, and that gave me access to the Microsoft Build system, so I got MS Build, which is the same thing that Visual Studio uses to build, right? I nearly installed all of Visual Studio for Mac just so I could get a meme slide for this. No, you can't compile Windows code for macOS. It doesn't work like that. Sadly, although that would be extremely cool if it did. So instead, we have to go through the general process of actually cheating at a game, which involves writing the cheats, injecting the cheats, and then doing the cheats. But conveniently for us, we've already written the cheats. We just got to port the cheats. This talk is going to be about the injecting the cheats, which is the hard part, TM. And then doing the cheats, well, they do themselves. I mean, that's the whole point of the cheats, is they just start up when you load them, and you don't have to deal with it. So, alright, we're injecting into a process. What's the step for that? Well, first off, what are our goals? First goal is that we get the game to load our cheats, right? You can't cheat if you haven't loaded your cheats. Second goal is we don't modify the game, because, modifying the exe, or I guess on the Mac case, it doesn't have an extension, is really bad if we want to deal with updates. It's really bad if the game has signature checking. Mac anti-cheat is a giant magical mystery cloud, but let's just assume we're not modifying the game. And the third goal is that when we load the cheats, they start. And conveniently for us, cheats load themselves. So, injecting into the process. A lot of this talk, you're going to hear the repeated theme of don't reinvent the wheel if you don't have to. So there's this really cool tool called mock inject, which injects processes on mock, which is the kernel for macOS. And if we load up their GitHub, you'll notice my Vermont internet is really bad. If we load up their GitHub, we will notice it's got all this fancy stuff going on and blah, 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 huge C file full of mess. What a wonderful, wonderful code base. But one thing you'll also probably notice is the issues page, involving lots of versions of macOS that apparently it doesn't work on, which is extremely fun considering that those are all before the version of macOS we're using. Bodes well. So, yep. Unfortunately, it's old. It's, in fact, too old, and it doesn't work no more. So, what happened? Well, unlike Windows, Apple doesn't really guarantee that your process injection actually stays compatible. Like Windows, you can just, I don't know how the hell the API does this, but they maintain that if you inject and create remote threads, it actually works. And Apple is like, you're not supposed to do that. We're not going to let you do it, probably. And if you do it, we're not going to keep it compatible through the future. And as a player of old video games, I'm really sad that Apple is so bad at backwards compatibility for this stuff. Like, the latest macOS, they just removed all of Carbon, so all of the old games don't work.
Oh my gosh, I didn't even realize that.
They basically removed all of Carbon. Because they never built it for 64. Thanks, Apple. Convenient. Convenient water bottle. So, seeing this, people made new tools. Notably, this guy called Scott Knight has this whole blog post about injecting code onto macOS. And he used this file known as inject.c, which is just basically a whole bunch of different people's process injection tool, iterated over the years, and he basically found a bunch of extra stuff you have to do on the new macOS because threads aren't real threads anymore. So, hey, that sounds promising. Why don't we use his thing? So, this is where the fun begins. I couldn't resist. So, trying to run inject.c on the game, you'll notice a very conspicuous unable to create remote thread invalid argument. And if you look really closely at these pointers, you might notice that pthread create mock thread DL open are 64-bit pointers, and it allocated a remote stack, which is a 32-bit pointer. And you think, I wonder if that's the problem. And it turns out, yeah, this inject.c only works for 64-bit processes, and being the well-established game that it is, Assault Cube is a 32-bit process, because all the games are 32-bit processes. Why did Apple have to deprecate that? I don't know, but not losing any opportunity to put more prequel memes in the slides. I gotta put the memes in. So yeah, we need a 32-bit injector to inject to this 32-bit game. Is it possible to learn this power? not from a sane individual, but I don't consider myself sane, so I guess that's where we're going. So all right, we're writing an injector. How do you do an injector? Well, you got to load a library into another process, but that's kind of vague. What does that involve? Well, you got to get a handle to that process, and you got to load the library. Well, load the library is still pretty vague. Okay, you get a handle, you give it some data that says what to load, and then you call a function that loads it. But giving it some data is actually more like 2 steps. It's like create some memory and then write the data. And then calling the function is actually a couple steps too, because you have to find the function first, and then you have to call it somehow. But like, how do you call a function? You aren't that process. So it actually involves creating a thread in that process that calls the function, that loads your library, using the data that you gave it, all through this handle, and it's like a multi-step process. It sounds kind of like a mess, but hey, we did all this for Windows. We can probably do it for macOS. But first, how did we do it for Windows? Well, if you want to open a handle, you just use open process. Thanks, Windows. If you want to create some remote memory, you just use virtualalloc ex. I guess the ex is there because the first one wasn't good enough. If you want to write your data into that process, you just use write process memory. If you want to find functions, just get proc address, get module handle, there's a bunch of them. And if you want to create a thread, you just create remote thread ex. Again, ex because Microsoft. Thank you, Microsoft. So, what's this look like on macOS? Well, on macOS, many of the things are very similar. Instead of calling open process, you call task for PID. And task for PID is notoriously hard to call. You basically have to broot and turn off security, or otherwise compile the binary with a special flag that says, hey, let me call this. Or I think be an Apple process. It's a mess. And virtualalloc ex is just mock VM allocate. I mean, yeah, it's just a whole bunch of mock functions, basically. And they all work kind of the same way. They have different parameters, and you have to give them different random stuff, but basically the same thing. So, strategy. I'm not made out of free time. As much as it seems like I'm made out of free time, I actually like going to sleep. So we're going to copy pasta as much of the original code as we can. And I mean, the inject.c thing got pretty far. It created a remote thread on the process, even in the wrong address space, mind you. That was really cool. So let's just patch up the parts that are broken. So which things are broken? If it does work for 64-bit, it'll probably work for 32-bit. So, here's our list of inject things. Let's see which one of these are working. So, getting a handle to another process? Yeah, it did that. Create some memory on the process? Yeah, it totally worked. Write the data? Well, the data was a 64-bit pointer to a string, but hey, that's not too bad. We can fix that. Finding the function, dlsim gave us the 64-bit address. But if we compile as a 32-bit program, dlsim will give us the 32-bit address, and then we're fine. And then create the remote thread. Well, there's a whole bunch of structures and stuff that make it a 64-bit thread. So we're going to have to change basically all of that. So here's just a summary. Basically, half of it's already done. The other half of it, we change all the 64s to 32s. And if you want to compile C for 32-bit on macOS, you have to speak the magic incantation, which is gcc-m32-arch3iad6-sysroot equals full path to an SDK that's not 10.14 or higher. And then it will still throw warnings at you and be real angry. So you just get used to it. And when I say for the final one, swap all the 64 thread states with 32 thread states, I mean, I literally just open the file, Control F64, and replace with 32. And it actually works surprisingly well. So looking at our list of stuff, it seems like there's no problems, right? It seems like we just covered basically all of the steps and we should be good to go. Except there's one hidden step that we didn't really realize, which is that the thread that we create runs shellcode, which is like super duper architecture specific because we just give it a bunch of raw x86 and it runs it. So we have to rewrite all that to be 32-bit. So that basically is the main gist of what we're doing. So if you look at inject.c right at the top, you'll notice a giant blob of shellcode. It looks extremely fun, and I definitely want to write some of this. Oh man, I love LEA-RDX keyword pointer rip plus hex 21. That fills me with joy into knowing exactly what the hell is going. What's going on? Alright, so let's see. Let's break it down a bit. So this first blob of shellcode is basically just a function that creates a thread and then spin loops forever. Alright, that's a lot cleaner than just a whole bunch of assembly and bytes. Second function calls dlopen and then spin loops forever, which is like, I guess they're both spin looping forever, because if you stop and actually return, it'll crash. Thank you, macOS. But pretty obvious. So the thing about writing shellcode is, as much as I enjoy x86, which is not very much, it's a pain, and it's tedious, and it's tricky, and it's hard to debug. And wouldn't it be nice if we could just write C and get shellcode out of it? If only there were a tool that let me write C code, and it gave me shellcode. Oh, wherever would I find such a tool? Here's the
like
shameless plug.
Binary Ninja. Wow.
What are the chances? Thanks, Binja. I mean, they pay me not to make the talk, but they pay me for all sorts of other things. And they've got this super convenient shellcode compiler that you give it C, and it gives you shellcode. And it's got a whole bunch of nice features, and it's not R2. For all of you in the audience who think, hey, we should use R2 for this. I mean, you go ahead, use R2. Let me know how many hours it takes you to figure out the command line parameters. SCC, you literally just give it some C code, and it works. Something to be said for usability. So, I just copy-paste that translated C code, throw it into SCC, and it nearly worked. It's actually surprising how well it worked. So the one thing it doesn't get is that SCC doesn't know what a pthread is. It doesn't know what pthread create from mock thread is. You basically just have to tell it, hey, here are the functions, here are the types. Please assume they exist. So you just use pointers or function pointers, which are honestly the worst syntax I've ever seen. And you just say, hey, yeah, pthreads exist. And I'm going to call this function, and it's just whatever address. I threw in a whole bunch of ones. We're going to have to go through and replace it later. But for now, it's close enough. And similarly, with the other function, you literally just do the same thing, copy the code in, define the types and the functions that you need, give it to SCC, and it literally just spits out shellcode. It's that easy. You just say, here's my code, and it says, here's some bytes that are x86. I see the people in the chat trying to say R2 is great. Yeah, Kibo, R2 is great if you want to have a manual open all times of the day while using it. Definitely not a paid shill. Alright, so cool. We've compiled our shellcode. And then the harder part is we got to take all those ones out and replace them with not ones, but like the real addresses. And it turns out that the inject tool already does this for us. It just goes through the code byte by byte and mem compares each location. So I just took all the mem compares and replaced them with 11111111 and used the right address and had to change all the uint pointer 64s to uint 32s. And I mean, okay, convenient. And hey, would you know, that actually worked. And when I say that actually worked, I mean after the many hours of it not working, I actually got it working. But as you can see here, this is a lovely screenshot, the demo later, lovely screenshot of a salt cube running in my terminal, and then it says hacks loaded. And something tells me it doesn't say hacks loaded normally. But, alright, what else can we do to the shellcode since it works? Well, it has a whole bunch of wild true threads, and just running the game already heats up my poor Mac, so we probably want to stop those threads. And if you're lazy and it works, you just throw in a sleep and then a thread terminate, and you just have the inject process kill the thread, and you just say, please stop running. If you are less lazy and try harder, you over-engineer a wacky multi-stage thread spawning and terminating system. And that's on GitHub if you want to enjoy that. But turns out the dumb way for doing this works fine. Who knew? So back to our general process. Now we have effectively injected our cheats into the game. So now all that's left to do is port the cheats. So this picture here describes how one would port the cheats. But I was looking at this for a minute and I was thinking, this seems a little out of place, because aren't we using macOS? So with a little bit of photoshopping skills, we have porting the cheats on macOS, because macOS users don't hit Control-C. Alright, so how does one port the cheats? Well, I mean, could it be that easy? You gotta ask, is it that easy? So here I've just taken the old cheats that Matt wrote and thrown them into GCC again. Internet. Come on, Internet, you got this.
Stream is dead. Crab. Crab.
Stream is dead. Crab. There it goes. It came back. Alright. So imagine for a minute you're really lazy and you don't want to port all the cheats. So instead of regular copy-paste, you use advanced copy-paste, and you just comment out the parts that give you errors. And what do you know? You get new errors. And, you can get surprisingly far with just commenting out the parts that don't work. Like, well, the main part of the cheat that we really have to port is DLL main. Because on Windows, it'll call DLL main when you load your process. But macOS doesn't have DLLs, so the equivalent is just constructor function. So attribute constructor with the weirdest syntax, you can thank GCC for it. And, just comment out the part that doesn't work. And see, what else we got? Well, literally just commenting out the parts that don't work. Like, not actually joking. Feels game dev, man. Just keep adding slashes until it works.
Oh my gosh.
So,
This worked.
Yeah, getting the key state, if you hit numlock or numpad, there's no function for that on macOS. You have to do a whole bunch of event handling and having a window, and I don't want to deal with that. Aimbot equals true. Just turn it on all the time. I know I want to aimbot. And see what else we got. Well, Windows, you had to allocate a console and open con out, and blah, blah, blah. macOS already does that by virtue of it being macOS, so we don't need to do that. But the real killer one here is my favorite. On Windows, you get module handle, so you can figure out where the base address of the game is. But on macOS, on old 32-bit applications, there's no ASLR. The game is just
Wait.
always loaded at hex 1000.
Well, like globally? Like
Globally,
any
yep.
32-bit app.
Yep, that's 32-bit, hex 1000. Everything below it is like read protected, so you don't null dereference, but it just loads it at a hex 1000. Yeah, statically defined in the binary. Thanks, macOS.
ASLR is overrated.
I mean, who really needs ASLR when I can just inject straight into the process? ASLR ain't gonna stop me. I got root. So, it turns out after commenting out all those things, it actually worked. Like, literally, that was it. I just commented out those parts, and then GCC is like, yep, looks good to me. Chat says Pi or ASLR. I guess Pi, but they're the same thing, basically. I guess Pi is a better term for it. It doesn't relocate the base executable. I guess the libraries are still off and who knows where land. But yeah, literally that's it. You just comment out the parts that don't work, and then you port the cheats. And you might say, cool, let's inject it, right? So let's inject it. And you find out that, yeah, okay, it compiled, but you can't just copy-paste Windows pointer addresses into macOS. That doesn't work. They are entirely separate builds of the game, it turns out. Who would have guessed? So you get to go find those in Cheat Engine. And here's the part where I spent like 2 hours figuring out how to use Cheat Engine. Or if you can see here in the output, it goes, hey, the local player pointer is at some garbage, and then the entity list is at 38B, and then segfaults. That's not what it's supposed to do. So hey, let's throw it up into Cheat Engine. So Cheat Engine on macOS. Apparently it's real. It sort of works. It is like some sort of weird trial thing for their Patreon. So if you don't give them money, it'll yell at you every hour and be like, please give us money. I'm quitting now. But then it doesn't actually quit. But then half the buttons stop working, but then it keeps working the rest of the buttons? I don't know. It was weird. Oh, and the fun thing about Cheat Engine is that it looks like actual garbage on macOS because they used like Qt and some default theme thing. And if you have the macOS dark theme, it doesn't really know how that works. So as long as you don't care about the UI looking good, you can use Cheat Engine on macOS. Also, it runs as root. Yes, that means the UI runs as root. So all that UI goodness, I hope there's no bugs in any of it. And if you say, remap your keyboard to Colmac, it doesn't know about it. But it does the things, and it does work. And if you're paranoid or rather smart, you should probably do this in a virtual machine, because otherwise you're just running some random software as root. So after a couple hours of poking around, I found the addresses. And when I say I found the addresses, I mean we never actually implemented auto trigger bot, so I just didn't find the function that we needed for that. But the rest of them were there. And yeah, that's it. Flag. Game cheat. So hopefully the demo works for this, because it's pretty cool how this works. So I've got over here, it's the shellcode. It's literally just a bunch of, well, copy paste. The actual injector is, don't tell anybody, but I included a header file in the middle of a statement. I don't recommend doing this, but when you're lazy and you know too much C, you can just do this. And I have a convenient Python script here that takes the output from the shellcode compiler and throws it into a header as a giant string. So it just pastes this giant string into the code. and it's great. All of this is just the copy-pasty bits. And then the part where it actually does patching, yep. I thought it could look more cyber, so I had it print out the code. And then, yep, all the thread state stuff, you just changed the 64s to 32s and the RAXs to EAXs. Surprisingly effective. And the game hack is literally the same thing, including Matt's beautiful pointer syntax, which, thank you, Matt, for your pointer syntax.
Oh no.
Have you
worst
It was
hack
at least 3 deep at one point.
Yeah, I think there's a triple pointer in here somewhere.
It lives on
The triple
in
pointer
macOS.
will never die.
Remember this the next time you're thinking you're going to write some code and no one will ever reuse it.
Yep. Let this be a warning.
No.
And yeah, so over here I got a very nice makefile that I've been using to actually build this. Highly recommended if you're going to do a bunch of hacky stuff, use a makefile to automate doing all the hacky stuff, because if you have to type 5 or 6 commands and click a button every time you want to test your hacky stuff, you're going to lose your mind.
I feel attacked.
Yeah. Yeah. Like, literally with this, I can just type make run game and it will run the game. I don't have to click on the desktop. I don't have to find the settings. Nope, just make run game. And if I want to inject into the game, I just make run inject, and it, because it's a makefile, it depends on the cheats, so it will auto-build the cheats if they're out of date, and it depends on the injector, so it will auto-build the injector if it's out of date. And the injector depends on the shell code, so it'll auto-generate the shell code if it's out of date. You just, it's so much better having a one-click solution to running your code that I don't know how anyone lives without doing it. Insert CMake plug here. Alright, if you want to do this with CMake, be my guest. I'm going to pass on that one. But as you can see, it prints out the code, and I actually threw it into Binja because I have Binja and I might as well see what it does. And it's basically just a whole bunch of x86 nightmare stuff, because it takes some address and it throws it into EDX, because that's what Binja, or that's what SCC used as the stack. And it's not even word aligned. It's like EDX plus 57.
What?
Thank you, SCC. But yeah, it looks like this. It just pushes some stuff and it calls a function and then it loops forever. And the function it pushes, it just does some more stuff and it loops forever. Pretty basic. So, let's see if I get this to work. We make run game, and it just runs the game. And it starts on my other monitor because macOS is like that. And turns out Assault Cube on macOS, if you start a game with... Oof. There we go. You streaming again? Yes. Thank you, stream.
With the delay, the cutout just hit now.
Yeah. Hopefully
There we go.
whoever does the stream next week doesn't have this problem. So yeah, Assault Cube does not make bots. So apparently the solution is just start another match, and then it does make bots. That's cool. Thanks, Assault Cube.
I think there's a console command you can use.
Oh well.
bot_add.
I can hear my teammates dying in the background. So then I just run the injector, and there we go. We have cheats. They are actually the exact same cheats, and I've actually lost all the bots. I'm kind of bad at this game. Oh, you can't see where you're going because... There we go.
You can't see where you're going because you're busy you're looking at people through walls.
Can't see where you're going because you're looking at people through the wall. Exactly. So, Matt's cheats. I'm throwing you under the bus here for this one, Matt. Your cheats aimbot my teammate.
Oh.
So
that's
while
not
they
good.
aimbot the enemies, they also aimbot my teammate, which is extremely inconvenient if you
We only tested it in deathmatch, remember?
you only tested it in deathmatch.
It wasn't a team deathmatch.
Alright, well, imagine I wanted to play team deathmatch instead. So, as part of the demo, we're going to fix this. So, the key is we find our hack over here, and we just, don't attack our teammates. Pretty basic. If their team number is the same as our team number, don't target them. But I'm using this as an extremely good example of showing off having a build process. Because I can just be like, hey, here's game, and I just edited this file, and I have to press 8 million buttons to actually get in a mission, and then I just type make, and it takes a second, and now, oh, would you look at that? We're not targeting our teammates anymore.
Continuous cheat integration.
Continuous cheat integration. Only the highest quality... What the hell is that rendering? Highest quality cheats. And not being able to see where you're going. I guess we could probably patch in an off button, but off buttons are for chumps. We're all aim all the time.
Yeah, that rendering is
Yeah, the rendering is buggy. But hey, we've got cheats. But like, I keep dying. I don't really want to keep dying. So while we're doing this, we'll just throw in another cheat. Local player health equals 999. Just do that every loop iteration, you know, because... Oh yeah, and it also crashes when you quit. That's extremely convenient. But, I mean, I don't know what you were expecting. Turn on the aimbot when firing. The problem with turning on the aimbot with firing is I don't have a way to tell if the mouse is down, because that's hard on macOS. Oop, don't join a server. Oh, I could totally join a server.
Couldn't you just,
How
like,
long do you think it would
detect-
take them to ban me?
Can you just detect if the
Oh,
trigger
you know
has
what I
been
just
pulled? Isn't
realized?
there,
If
like,
we did this stream on Twitch, we would have gotten banned.
Oh no. Is it against the terms of service to cheat on Twitch?
Yeah.
That is...
What happened to like Brandon or whatever?
I mean, but we're not
Microsoft.
cheating, we're just making cheats. That's not quite the same thing,
I
right?
mean,
There's got to be an exception for that. It's educational
that's not-
content.
I don't think there is.
So like, I don't even have to aim. I don't even have to dodge. I got infinite max health. I can just stand here. Just hold down the mouse button. Game easy.
Oh god.
Yeah, it's just like 3 seconds. No problem. I really want to join a multiplayer server now and see what happens. Do you think they'll be mad?
I don't think there are a lot of people who play this online.
Alright, here's one.
No.
Alright, cool.
You turned to the dark side.
No, it just crashed.
It just crashed.
It just crashed.
Maybe
There's-
the health.
I don't know what that is. I bet there's probably some pointer or something that doesn't work.
You may have used an engine. But yeah, when you were looking for your pointers, you may have selected a server variable instead. So in
Oh, is there a
you can
separate list
see
for
which
client versus server?
object it comes from? Yeah. So you were probably hooking something on the server as opposed to on the client.
Well, let's see. If I join a different server, No crash? Crash. Darn.
Yeah. So one of those pointers is
Ooh,
over, but
I dropped the thing.
it
The
doesn't
server
matter.
has pwned me. Yeah, the server used my extremely old copy of macOS. The demo gods no longer favor us. Hey, I can try opening up Cheat Engine. Want to see how bad Cheat Engine looks? You know a process is extremely good when it starts off with please enter your admin password?
Oh no.
Yeah, it runs as root. Let's go, Cheat Engine. Oh, look at this, look at this. I have to hit the 3 button to enter the trial because I haven't paid them. I don't know how much of this I
I
actually
thought Cheat
want to
Engine
do.
was supposed to be open source.
Cheat Engine might be open source. It's very
I think
Qt.
it is. That's why I don't.
I don't know. You can see the giant mess of all the variables and stuff that I was looking through. I feel like trying to go and find all these addresses is going to be 15 minutes of you watching. I don't know, Matt, you're here. How the hell do I use Cheat Engine?
Oh boy. For finding what addresses?
We're finding the client list of
The client.
entities or something. I know it's in there somewhere.
So the player struct has the player's name in it. You could probably do a search for a string of the player's name when you look at them versus when you don't. Kind of how you find the trigger bot thing, but so if you load a bot and then search for the bot's name in memory when you're looking at them,
Yep.
and then look at another bot and look for changed string, or look for the other bot's name, you'll get a pointer that there's a function that returns a pointer to the entity that you're looking at, and you can then do a pointer scan for that entity, and you should find the entity list somewhere in that scan, I would think. I don't remember how I did it for the talk, but that would work.
Yeah, it sounds like a lot of work. And last time I tried to do a pointer scan, it took like 15 minutes.
Is there another bot that you can look at?
That actually, the value has not changed, which is like, cool. Yeah, the other bots spawn over here.
Yeah, if you look at another bot, it should change.
Oh wow, it actually did change.
Yeah. That is like, so the return value, if you look at that code, if you write, if you
let's see, we got
control click on the
I got a mouse.
If you control click, I imagine you will get
probably gotta browse this memory region.
I would look at find out what writes to this address.
That sounds like a smart idea.
And then look back at the bot, then disassemble that region, and you'll see a function called
wow, that's extremely good.
Yeah, it's super nice.
All right, we got a function call.
And if you go into the disassembler and do a few up, you can set a breakpoint and then look at the register value that EAX points to after that function call, and that's a pointer to the entity that you're looking at. And then you can do a scan for that value throughout the memory region, and one of those is going to be in a list that refers to all of the entities. So you just look for the one, you right-click Browse Memory Region.
Hardware breakpoints? Yo.
Yeah, it's interesting.
And then EAX is some random nonsense.
Right, and that's probably that should be a pointer to the player object of whatever you're looking at, right? And then
access violation. Oh no.
Uh-oh.
Alright, well, Cheat Engine just crashed. Thank you, Cheat Engine.
Oh, you didn't set a breakpoint. I'm sorry.
No, Cheat Engine didn't crash. It just threw up a dialogue and I don't have to care about it. This is
interesting. Cheat Engine is definitely in beta on.
Yeah, yeah, it really, really
It's
is.
close to being really cool. This is working surprisingly well on macOS, I would
Oh.
think, in general.
And then it has actually just stopped debugging. Cool.
Okay.
Right.
But yeah, there's a function called slightly above where it writes, and it'll say call or whatever, and then it does something with the value and derefs it and goes to the name offset and prints it. And that function, right after that function is where you want to break it. But and then you
Okay.
could take the value in EAX and
Break and trace instructions. Oh god. Oh, that's a lot of options. Yeah, I don't know. I'm gonna just finish up with the slides, and then after that
Yeah.
we can keep trying to get this to work. So I want to call that demo successful, though,
Yeah.
because the cheats worked, the changing of the cheats worked. The only thing that didn't work was screwing around with memory. So that just leads us to the conclusion, which is that hacking Mac games is wonky. It's way easier if you just take someone else's code and change the parts that don't work until they work. Like, if any of you want to hack Mac games, now you can just take the parts of the code that I wrote, and if they don't work, change them. But honestly, just use Windows. I mean, the anti-cheats are way nastier, but the cheats are way better. And here's a GitHub link to the actual project where me and Matt and Devin spent way too much time trying to get the threads to stop working, and it turns out you can just tell them to stop. It's pretty cool. And I threw in one slide at the end because updates for anybody here who's in the club and looking for stuff. Next topic is Friday at 6. This one was Saturday because good old demo stream YouTube didn't let us. We had to wait a whole bunch of time. So next talk will actually be Friday. Same place. We'll send a link. Tools website is happening soon, TM. And I don't know, be sure to stay safe and pass no credit comp.org, because oh my god, if there was ever a time, this is like...
As someone who is mentoring comp.org this semester, please, for the love of God, PNC. I saw your grades on homework too. You aren't passing this well, you're not getting an A.
Pass no credit comp.org. It's worth it.
It really is.
Graduate with a decent GPA. Alright, that's the end of the slides. So we can go back to
screwing around for a little bit.
Screwing around for a bit, trying to get this to work.
I gotta get going, but good luck.
Thanks. So we're just going to ignore this access violation and pretend it never happened.
Where's the leave chat button?
So yeah, I would do the find out what writes.
What's writing to it is stir copy, which makes sense, I guess. Stir copy.
Oh wait, it's different. Because it's different. It's
does the Windows one use like a rep move?
It inlined the mem copy.
Oh.
I think so. You can follow the stack trace up probably, and there's a function that should return a pointer to the entity.
I would follow the stack trace up if there was a stack trace. There is decidedly no stack trace.
Can you then just break on the first part of the function of the stir copy, and then look at the stack?
What a great idea.
Break on the push RBP and just look at the stack. But then we might be breaking on all the stir copies.
I don't think there are that many stir copies in here. Where the hell is the stack at? No, don't change the stack. Alright, well there's now a T in memory somewhere. That's great.
Oh, God.
Uh,
Don't change the stack.
too late.
All right, so if you go up to the top,
Oh, it's
there should be,
Control
like, view.
G. Thank you. Thank you, Cheat Engine.
Hopefully you wrote that into like
O10C A5CO. Yeah, that seems all right. A5CO.
you're just ignoring the access violation. I don't even remember.
I mean, that's just sitting there. You don't
At least
really need
caught,
it.
I guess.
That is not the right address.
If you right click and click, I'm gonna go to address. If you do tools or view and do view memory or something, or like dissect data structure, I think that's the function I'm looking for. But there's like a
Huh. Oh, you know what? I bet
wait,
there's
no,
like
you
2
don't want to
steps
do
to this bastard or something. Here. And that should be
Oh, there you
EBP. Here's the part where I wish the Binja debugger supported macOS 32-bit, because it currently doesn't. And hello, everyone who
Cheaters are
joined
certainly
late.
good at certain things, like their watch point stuff
Yeah.
is top tier.
For everyone who
But
joined late, we had slides about how to write shellcode and then not actually write shellcode, just write C code instead and compile it into shellcode because you're lazy. And how to take somebody's 64-bit injection tool and rewrite it into a 32-bit injection tool. And I'm going to pull up the copy-paste slide because it was just so good and everyone needs to see it. We can all agree the real way to write a game hack is waiting 8 years for Drive to load because streaming has actually just melted your computer. I love it. Here it is. I'm just going to keep this open over here on the side and you can enjoy it.
Stay safe. Pass no credit comp or all you can.
Yeah. But now we're going through memory trying to find wherever the client cheats are. Oh, don't type a G in memory there. Oh, that's not a good sign. Oh no. Alright, neat. That's exactly what you want to see. So I see, if we want to find the real return address, we follow the base pointer until it points us out of system memory. Yes. That looks like still system memory.
Oh my gosh.
Do you have massive brain? Let's see what that's at. That is the thread list. The upside down thread list, I might add.
You're doing this in hex view.
If you can't use a hex editor, what are you even doing with your life? Yo, guess what?
Did you get it?
What the heck is this? No, actually, I didn't. This is something else entirely. That breakpoint has hit way too many things. That is SDL soft stretch.
Oh no.
Let's try this, but better.
It's big brain time.
It is extremely big brain time. Hit thing, and then we follow EBP. Yes. Wow, that got out of stir copy way faster.
Ooh, that was good.
Here we go. This is calling something. I guess we're just going to throw a salt cube into Binja. Because we've got Binja open, we might as well throw a salt cube into Binja.
Oh, yeah, that would work too.
Call plus 70760.
It's no
Plus
ASLR, you
base
could just copy
address.
paste the address.
Here we go. This is doing a whole bunch of math and a whole bunch of
Math.
rendering. Somehow I still feel like this is not the right function. Don't forget to like and subscribe. Be sure to smash that subscribe button.
Or is it calling stir copy? Let's see.
Go back to EIP, please.
And if you look above it, you should see it, right? What you'd be expecting to see.
07C564.
Is the name offset
Here.
still in the code that we were looking at? Like, because you should be seeing it deref, like,
Oh, I see. Like the pointer for this name thing?
right, like it'll deref like EDI plus OX22, whatever that offset is,
Okay.
and it will load that into one of the
Yeah, that's
arguments
the right
for stir
address.
copy.
Huh. Here's the part where I open up LLDB and embarrass myself with a better but still really bad debugger. How does the stack trace not work? Really? EBP plus star? Full stack? No, that is the stack. That's not really what I wanted. I wanted a stack trace, but the trace doesn't work, which is inconvenient.
macOS. Feels macOS.
Feels macOS, man. This is why you don't hack games on macOS.
Because the tooling is non-existent.
I mean, we could just, we can open Xcode. What a great idea.
Gosh, Glenn.
Do you think, no, you can't attach two debuggers to a process, right? There's no way.
I don't think so. Every platform I've ever used does not let you do that.
So you're telling me there's a chance.
It is macOS. I don't know.
Come on, Xcode, you got this.
They pretend to have ptrace on macOS, and then it doesn't work.
It's
So-
almost
so
real.
They tried.
All right, it just spawned. No, wait. Is this the same as? Oh man!
You have two debugger. That is
Oh, man.
broken though.
I don't-
What happens when you have breakpoints?
All right. Here we go. Let's see if I can. This memory viewer is very confusing. Is this the most macOS thing you've ever seen? Having two debuggers attached to one process?
How is this possible?
macOS hears all of your sane architecture principles and it just throws them out the window. Yeah, wow, Cheat Engine is still connected. All right. I guess we're gonna throw a breakpoint at stir copy.
2 debuggers on one.
Oh man. I wonder if it's gonna do that thing that macOS does when you hit a breakpoint where the audio just dies. Oh, I bet the audio is just dying.
Oh, for games.
Oh my god, the audio is destroyed. Alright, Matt. Well, if you're saying words, they sound real bad. It gave me a different address. So if we throw that new address into Binja, here's the stir copy. And I think this is probably the function because it tests it. Yeah, it calls this bastard, and then if that bastard is 0, then we skip it, but if it's not 0, then we don't skip it. And if it's not 0, then we stir copy it into here. So it's probably this one. So we got to take this address. Oh, and I might as well hit continue while it's oh no, oh, it's breakpointing in every thread. Thank you, macOS. All right, robots should probably have stopped.
Am I good?
Yeah, you're good now.
Okay. I was intentionally not talking. So.
This is an offset from the base address, so we have to subtract that. And then if we just turn TriggerBot on, and because we haven't injected into the game yet, right? So we can still load our cheats into the game. This game is now going to have 3 debuggers attached to it. Hey, see, it says entity found. Entity found. Entity not found. Oh, that was the easiest reversing I've ever done.
So there you go. That function gives you the entity pointer. So if you want to find the entity list, you search for that pointer.
It's a good thing I print out the value that it gives me. It's a good thing I can spell entity correctly. Real live cheat development. Just hitting enter a bunch until it works.
Just hitting enter until it works. Just copy paste.
G++ is taking so long. Alright, that entity is at 5317,600. So we pop back over to Cheat Engine, reopen our game, even if it's access violations. No one cares, Cheat Engine. Yep, keep the current addresses. Cheat Engine is now frozen. There it goes. New scan for 5317,600. That is not a string, that is a hex. Wow, that is used in a lot of places. So I guess what, pointer scan now?
I would do yeah, I usually right click, well, I usually do it with a pointer scan and look for.
Well, here's the current pointer, current entity pointer. You can tell because it changes.
The thing is, at this point, you would want to scan through, right, and look at offsets and kind of be like, all right, at offset whatever should be a valid health value between 0 and 100.
I mean, if this is the player structure, we know it's that. We just have to figure out where the hell it is, or what points to it.
Oh, I see what you mean. So, yeah, another thing you could do is find another entity and look at the distance between
It's
the pointer values, because they should be in a list, right? Like they're in a
yeah,
vector. Pointers to
they are 600 apart. So I guess this first one, we browse that memory region.
right. And if you browse the memory region, and then you go into like tools, dissect data structures, or it's in view, dissect data structures, it'll auto parse and it'll be like, this is a pointer, this is an integer, this is a thing. You can kind of like follow the pointers, and you can see, all right, all of these are pointers, and when I click on them, the first like 4 values are the position, which means that it's probably a player, right? And if you
Yeah.
have like equal spacing between all those pointers, you know you have your entity list.
Keep throwing up the thread list. Stop. I know it's an access violation. No, I don't care. You can't stop me. Yeah, so this is clearly how it works. We dissect this bastard. Well, no, actually, we want the first one, which is 531700. Oh, that's the slowest scrolling I've ever seen. All right, well, you get to wait 5 years as it scrolls up. Thank you, cheat engine. Are you done?
Oh man.
Yep, so here's the first player object. So we probably want to find things that point to that bastard. Although that should just be a big old list of structures or something.
Yeah, it's stored in a list of pointers to player structures.
This is probably out in heap land somewhere. So if we pointer map,
it might be. There's a chance it's just a static offset from the.
I mean, it's got to go back to static memory somewhere.
Right, but I don't think it's I don't think the list itself is allocated. It's like in some engine on Windows, I think.
Pointer scan.
Oh wait, no. On Windows, static offset to a pointer to the.
Good, the pointer scan doesn't work.
Oh, the pointer scan doesn't work?
Structure spider. Does that work? I've never used this tool in my life.
What is structure spider?
I got pointer maps working the other day.
Does structure spider do what I was saying with the looking for like signatures of the structure itself? Right, like if you find a player structure, you name it player structure in the structure dissector thing.
Here,
and
there
then
we go.
look.
Pointer scan for this address.
Alright, cool.
And then probably wants a pointer map. Please fill in an address. There you go. Save it to test. That's how you spell test in Colmac.
It's likely only going to be a few layers of indirection.
Yeah. How the hell do you tell it to do fewer layers of indirection?
So you can do that in the dialogue in the beginning when you start the pointer scan.
Ah, okay.
Something I think I literally did to do this was just do the pointer scan, add all the addresses to memory, close the game, have Cheat Engine save the pointers that it added to the address list, and then restart the game, and whichever ones are still pointing to what looks like an entity list.
God, my CPU is dying. Alright, well, Cheat Engine has effectively crashed, so let's just send it a couple SIG kills. Thank you, macOS. It's a good thing I saved all my structures. Haha. Didn't need that function anyways. Okay, and then we generate pointer map. Save as a salt cube, or Colmac equivalent of a salt cube. See, we've gone from super formally prepared slides to running cheat engine and 2 debuggers. Is Xcode still debugging? No, alright, get out of here, Xcode. No one loves you. Then, as cheat engine generates the pointer map, it takes 8 million years. Probably doesn't help that the game is spamming output in the background. Write that to disk. Thank you. And then we pointer scan. Use saved pointer map of that one. Scan for here. Max different offsets. Max level like what? 3. Try 3. And try it. This one feature of this stream is that all of the typing is in weird Colmac. Alright, we've got a couple places. Here's this one, which seems alright.
Oh, also,
Is
Yeah,
our server
search-
still running?
if you search and is it what?
Is the server still running? Like the RPISec one?
I have no idea.
Well, let's see.
Also, if you do a pointer scan for the health,
It goes
the
nowhere.
last offset should be equal to the health value, right? And then you look
Yeah.
for one with probably, right, there's going to be the health offset to a player, offset to another pointer, offset to another pointer. And you
My
look for
best
one
guess
with
is it's going to be either this bastard or this bastard. I'm going to guess it's this one. 11D908.
So if you
And you got to subtract 1,000 from that. How do you actually do this? You deref it. And then you add a size of player to get the player list. So if we inspect this, can I memory that? Access violation. No, you're an access violation. Oh, no, that is the offset. So we actually want 11E908. Thank you, cheat engine. This looks like a pointer to a bunch of pointers. This first pointer goes to that, and the second pointer goes to, it looks like a different structure, which might be our player.
You can use the data structure dissector on what you think is the entity list, and then just do like generate new structure. Hopefully it works on macOS, and you'll get a bunch of pointers, right? Just in a giant list.
This is
And then you
my
can click the
plan.
drop downs and you'll see the player structures at every drop down if it's the entity list.
Ah. As we wait for it to finish scrolling, this looks like a real entity list though, which makes me think that the player list is actually wrong. Like, why do you add size of player to the player list?
Oh, that was because the first entity when you're on local is always going to be null when you're playing locally, because
Oh, I see.
you're the first player to join the server, I think.
Yep, I would just
So
set that to this, and we just say, easy solutions. Just skip over all the null players.
yeah, fair.
Alright, well, not being bothered to see if it's actually real, I'm just going to run this and see what happens.
Go for it. Sometimes it's easier once you already have everything in place.
Yeah. Most of the joy from this comes from oh, this will annoy these folks. Oh no, it's downloading a bunch of Minecraft assets. Cheaters are losers. Can I play? Oh, I can play. Does this crash my game? Yes, it still crashes my game. Darn.
Does it work locally
Uh,
in a bot game?
player list, entity list part 1, 0. Player list pointer, 0. That's not a good sign.
Yeah, that does not look like that was the right pointer or something.
Bots? No. Thank you, macOS. Oh yeah, it totally works on local.
What? Alright, well. But it did not work on multiplayer.
Nope.
So that was not the right address.
Great. What other addresses did we get? 12 AC. I already tried that one. A whole bunch of these are at wacky offsets. Alright. Now we just have to find the pointers. Entity not found. Let's go find ourselves an entity.
The look at trick is the
Maybe
cool
we should
trick.
stop the bots. The look at trick is extremely convenient. Oh, yep, there goes the stream. It does that from time to time. And it's back. Thank you, stream.
Alright.
It's how all the talks work, you know? Good talk devolves into throwing cheat engine at a game. So, I already got the game open. Might as well. And I'll probably do like 10 more minutes of this, and then if I don't get it, I'm just gonna go eat dinner.
Yeah. It's becoming time to go eat dinner.
It is becoming dinner o'clock very fast. There's like a dozen addresses all pointing to here.
One of them is the right one.
One of them is the right one, and the rest of them are not.
Do you know what? If you double click on the address, does it show you the offset to the module that it's in?
Oh yeah, these aren't in a module. These are all in heap somewhere.
Yeah. Yeah.
Right, pointer, scan for this address. You think using the old scan will work on the new version of the process?
That's what I'm saying. If you load that, some of them will still be valid, and you'll
Ah.
be able to see.
Compare results with other pointer maps. I see. And then we scan for that into test 2.
See, when it works, Cheat Engine is great. It has lots of potential.
What did
On
we do to
macOS.
deserve Cheat Engine?
On Windows, it just works.
On macOS, it almost works.
Yeah. It's almost there.
Wow, that got actually no results. Cool. I'm just going to try again and not compare. Wow, it didn't even save a scan. And here goes slightly more, and maybe it will get it. Extremely highbrow hacking talks here. Only the finest. Running Cheat Engine as root and playing old games. Oh no, the window has stopped drawing.
No.
It's probably fine, right? We just give it a minute.
This is where I draw the line. Cheat Engine
No.
as root. Also, hello.
Would you run Cheat Engine as non-root? It probably would still work, though. I compiled this game as a task for pid allow. I'm seeing some spice in the chat. This is how all good cheats are developed, by pure doing stuff until it works. Well, here's a different address that looks like it might be right. Screw it, I'll try it. What is at that address, actually? Oh, no, this one still seems like the right address, though. A8AC. Is that what I had before?
Is it?
Yeah, it is. It's right near all the other clients, or the other, like, num players and local player stuff, so it seemed too good.
Yeah, I got suspicious because...
Ergo installed Cheat Engine over my dead body.
I got suspicious because it was working before, and then when you switched it and we went to multiplayer, the pointers were all null.
I mean, that's happened.
Wait. We weren't skipping over no players before.
Oh no, do you think it was working this whole time? I swear, if it was working this whole time...
But you weren't skipping over the null player?
But we weren't skipping over the null players. Alright, try it. 12A8AC. If this doesn't work, I'm just gonna go eat dinner. I think we got through the gist of the talk already.
Yeah. Wait, you're trying to run it, right?
Yep.
Or no?
No
You just
entities
wanna
found, but it ain't crashing. Oh. Oh, you know what I bet it is? It kept doing this to me when I was trying to run it, is these pointers change. So I'm just going to copy paste a...
So much of this is literally the same code that we wrote for the other talk.
Oh no. Oh, it moved the window down because it kept trying to lock my cursor. Yeah, alright, so that works. And then if we join someone's server that's not password protected... Oh, it totally works.
Hey, that's what the issue was that whole time?
That was the issue the whole time.
How did we forget about that?
Alright, do you think it'll kick me if I'm cheating like this?
Yeah, that's working.
You should just sit around in the corner.
Is this working spectator mode too?
He's got their flag.
How long before you get banned?
Alright, well, I'm not invulnerable, so the invulnerable doesn't work.
Yeah.
But the cheating totally works. That was an extremely long and roundabout way to figure out that I had the right address the whole freaking time. Thanks to everybody who stayed with us.
I am getting CS to Overwatch
It
vibes
just
right
piped
now.
in my head. I'm like, wait a second.
Now we got-
We skipped the first player because it's null on local.
Alright, I'm gonna disconnect before they ban me.
Yeah, team killed.
Alright, and just in
shredded.
time, I'm gonna call that a success. This is shaping up to be extremely reminiscent of your talks, Matt. Where it's like, is it gonna work? Is it gonna work? Is it gonna work? Alright, we're gonna stop it this time, and if it doesn't work, then we're done, and then it works.
Yeah.
Although we did have less
I got
trouble
it
with
down to
geometry.
the minute.
Hell yeah. Well, it's 1929, so I'm gonna call that close enough. The answer was copy-paste the pointers inside the while loop.
Yeah.
Now that's cheating. Anyways, thanks y'all for watching. Be sure to not run cheat engine as root on your system. I don't recommend this. Be sure to check out the shellcode compiler because you have to buy Binja to get it. Or if you don't, you just spend 8 hours trying to connect GDB or GCC to stuff. And GDB, right? No. And write more makefiles.
Alright.
Yeah, I think that's about it. So, see you guys next
Friday,
week.
6 p.m.
Yeah. Hopefully the talk will be more organized than this because we'll know what we're doing. All right.